Alright, here's the recording for making a tower that has more than 4 sides, or a 3-sided tower, anything really other than a 4-sided tower. Step 1 is really some math, and this is what you need to consider. If you have a polygon like a triangle that has 3 sides, it has a total of 180 degrees, which means if you divide that, each angle inside is going to be 60 degrees. If you have a quadrilateral like a square or a rectangle, it has 4 sides for a total of 360 degrees, which means each interior angle is 90 degrees. Now there is a trend you'll have to see here. Every time you add a side to your polygon, we'll just go up to 8 for now. Every time you add a side to your polygon, you're going to add 180 degrees to the total interior angle. So it becomes 540, the next one will be 720, and then up to 900, and then we get up to 1080. Okay, so what that looks like is 540 divided by 5 gives us 108. 720 divided by 6 interior angles means that every interior angle is 120 degrees. Now, the more and more sides we put to this, the bigger and bigger this angle gets as it approaches 180 degrees. So imagine you had a billion-sided polygon. Every angle inside would be nearly straight because there's so many of them. They'd be almost 180 degrees. It'd be like 179.99999, and it would never actually hit 180. And then this next one would be, let's see, equals this divided by this, enter. So it's about 128.6 degrees for interior angle. So I wouldn't recommend doing a 7-sided tower. But again, on an 8-sided tower, if we drag that function down into here, 1080 divided by 8 gives you 135 degrees for interior angle. So anyways, that's how that works. There is an equation, and it's this box right here. The interior angle, which is this column, is always going to be equal to 180 times n minus 2, where n is the number of sides. And then the whole thing divided by n. For example, let's do it for a 4-sided tower. 4 minus 2 is 2. 2 times 180 gives us that 360 right here. And then you divide it by n, which was 4, gives you 90 degrees for the interior angle. So whatever number of sides you have, that's how you do it. So let's go with the hexagon that had 120 degrees for interior angles. And these are the numbers I want you to consider. 120 may be the angle that we type in. The supplementary angle to 120 is 60, because 120 plus 60 equals 180. So keep both of those dimensions in mind. Then we're also going to add 180 degrees to both of them, because it could be possible that you have to type in 300 degrees, because 120 plus 180 equals 300, or the 180 plus this, which gives you 240 degrees. So one of those 4 is probably going to be the dimension we use to figure it out. So we're going to go here, and we're just going to say this one's grounded, and let's take this guy right here, and we're going to stick him right there. So first step, just like with the 4-sided, we're going to flush the 2 tops together, that with that, apply. Okay, now they can still move anywhere except that they are coplanar at the top. So now we get a little trickier with this. We're going to do a constraint, and let's do a mate, and let's tell this back edge to be coplanar with this front edge. And let's say apply. And now I want to say I'm going to move that back out, and it still spins. Now I'm going to do the same thing the opposite way. I'm going to tell this front edge to be coplanar with this back edge. Apply. And now I'm going to put an angle between the two. And we're going to do directed angle. I'm going to tell this face and this face. Remember, I calculated 120 degrees for a hexagon, 120. And that doesn't look right because I wanted it to come out this other way. So let's try 60. And that doesn't look right either. Okay? And let's see what my other ones were. So I said 120, 60. I'm going to try 300. Let's go back and let's try 300. And that does look right. And if I look right down on this, they look perfectly interlocked. They look pretty nice from here also. And that's it. So we got it on our third bet of 300 degrees. And the reason we got 300, it was the 60 degrees plus 180. Sorry, no, it was the 120 plus the 180. Apply. And now it is locked into place just where we wanted it. And you would do the same thing for the other angles.